Thank you everyone for coming. I'm Pascal Welsch and I flew here from Cologne, and I did not take the train because I want to get back tomorrow very early because tomorrow is Carnival in Cologne and I want to be there. Yeah. I'm a Google developer expert, and this is now my third year where I'm talking about Flutter at almost every meetup here in Cologne and in Europe. Exactly 1 year ago, there was an exciting time for me because this is when I quit my job at an agency and I became a freelancer. And if you have more questions about that, we can definitely do this in the Q&A later today. Exciting times ahead because I stopped freelancing. So only a short period of time, and I create my own agency which is fully dedicated to Flutter because it turns out there are so many people out there who want me to build their Flutter application and I cannot do it alone. And I need support. Hiring. Also freelancers, of course. So the question today is, why are we using Dart? Why aren't we using Kotlin? Because I personally love Kotlin. And this is one of the few occasions where I can actually wear my Kotlin t-shirt. So, first of all, let's answer the questions, why are we using Dart with Flutter? The core of the problem they had is that they want to have development fast and they want to have fast runtime. And they did it with Flutter because Flutter has two compilers. There's one just-in-time compiler and there's one ahead-of-time compiler. And this just-in-time compiler basically gives you this fast development. This is how hot reload, this is what hot reload makes possible. And the ahead-of-time compiler compiles all the Dart source code to native code, which gives us the great performance if we build our release applications. Dart has another cool feature, and that's basically because it lacks a feature. It has no real access to threads. And the advantage of that is that there are no locks. There are no locks between multiple threads, and similar to JavaScript, there is an event loop going on, which handles all the asynchronous stuff. Because we have no locks and no threads, the garbage collector can be very well optimized, and this gives us very good performance. And together with the event loop, which handles all the asynchronous stuff, it is well built for user interfaces because it means everything is responsive and only queues messages. But everything is responsive, nothing blocks. So we have multiple reasons why Flutter chose Dart as a primary language. Technical reason, not only because it's Google and they want to use a Google language. I, at some point, came to the conclusion Dart won't go away, and we should really embrace it. We should make the best out of Dart, what we have, and let's make it as good as Kotlin, if not even better. Just a quick question here. Who used Kotlin in the past? Not like 50%. Who used never Kotlin before? The other 50%. Great. So today we will see some Kotlin features and how they were ported to Dart and how they can use there. If you haven't ever seen Kotlin code, you will still feel that it's a way better way to write code. So don't be scared. I first want to look at what makes Kotlin such a great language. And I quickly made up a collection here of my favorite features of Kotlin compared to Java. So why is everyone jumping over in the JVM world over to Kotlin, and what makes it great? I will go through this point by point. And let's start. And also, let's look what's already implemented in Dart, because some of these cool features already exist in Dart today, or for ages. For example, function type. We can declare a type which is just a function which has one property, which has one argument and returns some other type. You can define that in Dart, and that works great. Coroutines. That's a hot topic for Kotlin users because they don't want to care about threads. We only have a single thread unless we use isolates, but we have async await. And this is how we usually handle async code. And it's very similar to coroutines. Actually, when they were implementing coroutines in the Kotlin world, they looked at the implementation of Dart and only generalized it at some point. Type inference in smartcasts. For example, if you have if value equals null, then do this. And inside there is always the case that this value is null, and the compiler can help you with that. Things like that already exist in Dart for a long time, especially since Dart became a sound language with Dart 2.0. This is built in, and with every version of the analyzer and with every version of the Dart SDK, it gets better. String interpolation, that was the feature which convinced me back in 2014 to use Dart for my scripts. Because back then I was only doing Java development, and it was eye-opening that I can build something with just a script, just a tiny Dart script, and I can use something like string interpolation where I can use variables inside of my strings. So it looks good so far. The last thing is the operator overloading. Dart allows you to overload operators, for example the plus operator, and create your own way how plus is handled. For example, if you create a class vector and you want to add another vector to it, you can do that, and you can write your custom implementation. It doesn't have to be an integer. You can do whatever you want. Although Kotlin gives you more operators you can override, it's already implemented in Dart. After I had this list and I checked off everything which is already implemented, I asked myself, what can I personally do to bring the rest of the features to Dart? And with the small asterisk, I can only write libraries. I'm not the guy who writes compilers. I'm not the guy who is good at creating grammar for the language. That's what the Dart team does. I'm good at writing libraries, and let's see what I can do with libraries. The first thing I want to talk about is the non-nullable types. And if you are quite familiar with Dart and all the Dart ecosystem, and if you follow some of the issues in the Dart language, you notice that this is actually something the Dart team is actually currently working on. You can go to the Dartlang repository and into the language repository. And there is the official roadmap. Everything is open source, everything is public, and you can see what the Dart team currently is working on. And the biggest issue here, which is in the being implemented section, is the null safety. And that's exactly that. That's non-null by default. And they are working on this now for quite a while, and I'm very confident that they will ship it this year, almost early this year. What they did, and you can follow this as well because everything is open source, they forked the Dart SDK, and they just copied the SDK and created an SDK NNBD, non-null by default, and started converting the whole SDK to non-null by default. This means every function which is able to return null gets this question mark to the type, which means this function not only returns a string, this returns a string or null. And they are currently working on this. They are also working on tooling, and this will be shipped relatively soon. I cannot help with that. That's what the Dart team does, but it's coming soon, so let's note that. Data classes and sealed classes is another hot topic if you are following the issues in the language repository. And it's actually one of the highest rated issues. People really want data classes, and this is a feature which comes from the Kotlin users. Kotlin users are used to create small data classes. Here's an example for a data class user with a name and an age. And the compiler generates all the boilerplate code, like the equals method, the toString method, and all the getters and setters which are which people use in the Java world. This is on the radar, and my personal, I think this will be shipped as a next feature. So after they release non-null by default, where the Dart team currently dedicates all the resources to build this. This is the next feature they are working on. So maybe later, 2020, 21, we can expect data classes. It's currently being spec'd. This means it's already accepted and they are working on a specification before it's being implemented. So let's continue with the next one. Short lambdas. Initially I wrote Dart, then I wrote Java, then I switched over to Kotlin, and then I went back to Dart. And what I really missed coming from Kotlin were the short lambdas. A lambda, a closure in other languages. In Kotlin you just write 2 parentheses, that's it. In Dart you always write braces and the name of the argument and then the curly braces. And over the time, it's just so much boilerplate code. So for example here, the first line is how you currently write those lambdas in Dart. And the second and the third line are how it could be written in Dart. The great thing here is, although it doesn't have many upvotes, this issue is pretty far in being implemented because there are no breaking changes. This could just be implemented and everyone would be happy. No breaking changes, no migration. So I expect that to follow very soon as well. Let's talk about the elephant in the room. Semicolons. People coming from Kotlin or from Swift or from TypeScript, whatever language, to Dart, they hate the semicolon. I did as well, and now I don't think anymore about it. It's also very high rated, because yeah, it's the semicolon. The Dart team said there are higher priorities on the list, and I definitely agree. If I could trade semicolons for data classes, I would say, please give me data classes. The same for non-nullable by default. I want non-nullable by default. I don't care that much about semicolons. And the problem with semicolons right now is there are grammar issues which have to be resolved. This would be a breaking change. Currently it is not possible to remove the semicolons everywhere. It's a hard issue and they want to invest time in other parts of the languages. And I agree, right now I don't think anymore about the semicolon. Okay, we have 3 things here I want to cover in details. And this is data classes and field classes, immutability by default, and tons of extension functions. Those 3 things, they can actually be ported with a library, like I can write one, to the Dart ecosystem. And that's what I did. And I want to tell you the story. Yeah, here another slide about that. I first want to start how I ported the extension functions which exist in the Dart ecosystem, then how I created immutable extensions, and then how data classes and field classes currently work in Dart. I first want to tell you the tale of kt.dart. kt.dart started 1.5 years ago, and I was super sick that I could not have these cool extension functions. The one function that I really needed was associate by. I have a list and I want to associate the values by some property of that values to create a map. And I couldn't find it. So this is how it looks in Kotlin on top. I have a list of beetles and then I call associate by and I associate every value by some other value. Here the length. Don't worry, the print is wrong. I know there's a mistake, but it returns a map. What I could do back then was, so this was before extension functions landed in Dart. I could write a top-level function called associate by, put in my list, and then a second argument, I put in a lambda and map it to the length and then return the list. The result is the same, but the syntax is drastically different. And what I really like about those extension functions as they exist in Kotlin is that they are very discoverable. You have a list, you type the point, and you get an auto-completion of a list of functions you can do with that object. This is not true with the second one, where you have some random top-level function and you have to know the name. Oh, there is an associate by top-level function where I can put in a map. So I want to port that to Dart. And so basically the thing, what I back then thought is, I can do the first thing now. I can write the functionality, what associate by does. And then as a second point, once Dart releases the extension functions, and I knew back then that this will come at some point, I can just convert the syntax a bit and have real extension functions. And in the end, it would look like the third one, very, very similar to what we have in Kotlin. I wanted to have those extension functions now. And that's why I created my own collections. I started creating my own list and my own map, and this gives me the functionality to add new methods to it. So I created my own map, which is called kt.list and kt.map, and added those extension functions. And I could use it by just creating my list, and then I can call associate by exactly as I would expect it to work once extension functions land. This was the first iteration and it worked well. I converted all my projects to use those collections, and I could finally use the over 200 extension functions I wrote or I ported so far. Next, I discovered that Dart collections, and I mostly wrote extension functions for collections, Dart collections work, Kotlin collections work a bit differently. Kotlin collections always are immutable by default. This means if you create a list, you cannot change the values in that list. You cannot remove an item or add an item. You have to create a copy and add that item to that copy. Or you convert those collections to a mutable one, which means a mutable iterable, a mutable map. And those are really mutable. You can add and remove items, but by default, everything is immutable. This diagram looks completely different if we look at Dart. A bit simpler. We have iterable, list, set, and map, and everything is mutable. And once I wrote a lot of Kotlin, and I went very functional when I wrote Kotlin, I was so used to immutable stuff that I don't want to go back to immutable collections anymore. But I already created my own collections. I created my own kt map, my own kt set. So why not make immutable versions of it by default and create mutable counterparts? And that's what I did. So in pure Dart, if you're just using the Dart SDK, creating an unmodifiable list looks something like this. You use the constructor list unmodifiable, put in your list, and this gives you an unmodifiable list. And if you call remove on that list, it gives you an error. The bad thing here is that this error happens at runtime. This means if you accept a list in an interface, you have no idea if this thing is mutable or not. You can call remove and suddenly it doesn't work. It would be way better if remove would not exist at all. And that's what I did. The kt list here by default has no remove function. Remove only exists if you convert it to a mutable type. So there's the function toMutableList, and once you have a mutable version of it or a mutable copy, you can call remove. And this makes the API of my kt list or my mutable kt list much better compared to the standard Dart one. Because I exactly know those functions which exist, they work. And I don't have to add a try-catch around it in case it's not modifiable. Another thing I noticed is that collections in Dart work a bit different when we look at the equals operator. The equals operator in Dart compares the identity. This means if you have here two equal lists, they are not equal because you created them twice, and each one of them is a new instance. They are not the same. With kt.dart, you can create lists with this list of function, or you can use the constructor kt list off and put in your values, and it checks by the content of that list. This means this here returns true because they are equal, and yeah. So now I have two more features why my lists are pretty cool. First, they are immutable, and second, they handle the equals case. One workaround in pure Dart to handle this equals case is to use iterable equality. This is a function, if you have two iterables or two maps, whatever, there exist multiple versions of this equality thing. You can call iterable equality, and it checks if those iterables are the same. There's one for lists, and if you have nested structures, there's also deep equality. But every time you write your own, I call it data class, some object, some value object you want to use the equals operator, you have to write it on your own. And every time you have to write iterable equality equals, and you have to know if it's a map or a set or a nested, deep nested thing. You really have to know a lot. The in-Kino application heavily uses Redux. And with Redux, your objects care about the equals operator. And we exchanged the lists, the pure lists, the Dart lists, which were in this project, with kt lists. And suddenly we were able to remove a lot of boilerplate code and also, again, auto-generate those equals and hash code methods. Until now they were manually written and there were manual mistakes, but now once we use those great collections which support equals, we can now auto-generate the equals methods again. After thinking a lot about kt.dart and how if it's really a good idea to create separate collections which do not extend the Dart collections, I came up with this diagram. In the Java world, we have arrays, and in many other languages there also exist arrays. Additionally, in the JVM world, we have the list interface, which under the hood uses an array but gives you greater functionality. It cares about equals, there might be an immutable one. But array is just this plain object which holds multiple objects in order. It doesn't care about equality, it just holds objects. And when I compare the array to the list in Dart, that's more a match than the list from Java to the list to Dart. So I really thought, yes, there is a missing piece. We do not have what we call list in Kotlin. We do not have that in Dart. We do not have a collection which supports this equal operator. So actually my kt list, my kt set, they are really useful. They fill a gap in the language. Yeah, so even if this extension functions land at some point, and I don't need my collections just to give people the opportunity to use my extension functions, I still have value in my kt.dart library by having immutable collections which care about equals. This is a list of all the collection types I have currently supported. We have a list, set, map, the mutable counterparts, and also under the hood there is a kt collection, kt iterable, but you don't create instances for that, but you can extend it on your own. It's pretty stable now. I think the API is now stable for a year. I just converted it to the extension functions and everything still works. I use it in all my projects and I'm very happy to have it in my toolbox. Once Dart 2.7 landed, we got the extension functions. And the biggest problem I had with my kt.dart library was that people requested me to not only add those extension functions to my kt.dart collections, but also add it to the Dart collections, so for pure list, for pure Dart list. And I really had a hard time thinking about it. How can I solve it? And maybe should I create a fork of my library? Should I create another library? Should I mix it in to my kt.dart library? It was hard. And this is where dartx came in. And I'm very happy to have Simon here, because he's the author of dartx. And I discovered this library and it solved all my problems. What it does, it gives you all the cool extension functions which exist in Kotlin and port it for Dart lists and Dart maps, so for the pure Dart collections. It does basically the same as kt.dart, but for another collection type. So I told all my users, hey, you want those extension functions for Dart collections, use dartx. And I'm pretty to have it as a separate library, and I currently use both libraries in my projects. Because sometimes I have to use Dart collections, sometimes I can use my immutable collections. And for both collections I want to use all these cool methods. One of the coolest methods is chars, which basically splits a string into characters. There's no character class in Dart, but it creates strings with with the length of 1. And it handles emojis well and things like that, and I use it very much. And this is a thing which I would not add to kt.dart, because Kotlin doesn't have such a method. It wouldn't fit well. But it works great for the Dart ecosystem. So again, Simon, this is a repository, and I think by now it has way more stars than when I back then did the screenshot. I currently maintain this library as well. So if you have a pull request, a cool extension for any type in the Dart SDK, create a pull request and add an extension. For example, for Dart.io, I think we are missing many extensions there to read a file line by line. It's super easy in Kotlin, but now we don't have an extension for that. Add it. We got a question recently why dartx looks so much like Kotlin. Are we so focused on Kotlin that we ignore all the other cool languages? And that's not true. We care, or we create extensions which are great for the Dart language. And we are very inspired by Kotlin, because Kotlin is inspired by very much other languages, for example, by Java, Scala, C#, Groovy, Python, Nice, whatever. Kotlin takes the best of many languages and combines it to a great API. And we do the same. With dartx, we use the best what exists in other languages and put it into this extension library. So yeah, again, if you have a cool extension, please create a pull request and add it to this dartx library. We will all benefit from it. And yeah, also use it in your libraries. You can use it together with kt.dart. Looks great. The only caveat is it doesn't solve the mutable problem. If you really want to use immutable structures, you have to use kt.dart. dartx doesn't give you immutable counterparts. My personal favorite of an extension which exists in this library is the range2 operator, or the range2 extension method, because it gives you a way to iterate fast over two numbers. It creates a range between two numbers, and then you can iterate over it, and you can even set custom steps. And this is very useful for all kinds of coding challenges. Advent of code, for example, I used it this year, and I used this range2 operator like 5 times in all 24 challenges. Data classes. This is a pure Dart class with 3 properties. We have a constructor with named arguments, and they are required. Because we are good developers, we also assert that the values are null, because we define them as required. You shouldn't set them to null. We do not have currently non-nullable types, that's why we have to do it manually. Next, to make it a real data class, we have to implement the equals operator and the hashcode operator and write a nice toString method and things like that. For this, I use a plugin which generates me all that stuff. That's what this plugin generates. The plugin is called Dart data class. And it's an extension for VS Code and IntelliJ. It exists for both. And it basically generates you the equals operator, the hashcode function, the toString function, and most importantly, the copy with function. And with copy with, you can manipulate, you cannot manipulate an immutable class, but you can create a copy with different values. and basically change this thing over time. Yes?
Did you also look into build value, because that's doing the same?
Yeah.
Next
The question about build value, that's my next slide. Yes.
Because you can use those builder methods, and then it doesn't need to be a plugin, right?
Exactly. Yeah, I will cover all of that. Another question? Yes?
What are the pluses doing in there in line 28?
Create a pull request if they are disturbing you. So the pluses, I wouldn't write them, but yeah, that's what a plugin does. Raise an issue. Yeah. I used this way, or I created my data classes this way for over a year. So until 2 months ago, I created all my data classes manually. And it works fine because I was not a big fan of generating code. It was broken in the past a few times and I was a bit scared. So I created it on my own. It took a bit more time, but I didn't have a dependency to some build generator. The alternative is to use build value. Yes. To use build value, you basically define all the properties as getters, implement this build thing, and write factory constructors. It will then generate a class for you, which is defined at the very bottom. And this class is the actual implementation. This factory constructor forwards the arguments to that generated constructor, and it creates a constructor for you. Also, yes.
Is there a mistake because there's a get missing before text?
Yes,
yeah.
there could be a mistake.
I always screwed this up when I was using build value, forgetting those gets.
Yeah, one problem of build value, you have to be exact.
Yeah.
If you do one mistake, then the build value generator fails, or in the worst case, it doesn't fail, but it simply doesn't work. So I want to show you a new library, which was released, I think 1 or 2 weeks ago. So it's brand new, and it's called Freest. And Freest was developed by Remy. Who knows Remy here? At least the avatar. I think most of you should be familiar with Remy, because he wrote also the provider package. And everyone here should use the provider package at some point. He also wrote other cool libraries, and the newest addition to his collection is Freest. And Freest is better than build value. Here's an example how Freest looks like. You create an abstract class and you define one factory constructor. There you can define the arguments the way you like. You can use named arguments, you can use positional arguments. It supports everything. At the end you have to define a name, which is the actual implementation of that class. At the bottom I show you the example, so I create that user with named properties, and it also generates a copy with method. And that copy with method works way better than build value. The problem with build value is if you try to use null as a property, it doesn't remove the value, it doesn't set that value to null, it just uses what existed. That's a limitation from build value and other copy with constructs. And I don't want to go into much detail here, but Remy is super clever and he abused the language at some point, and he was able to come up with a solution that you can actually set values to null again. If you're really interested, just look at the implementation, it's super tricky. Another cool thing about Freest is not only there to generate data classes. Remy also created Freest to create sealed classes. Sealed classes is basically an interface with a fixed set of implementations. So the interface here would be result union, and the implementation would be success or error. And I think we all written code like that in other languages, especially in TypeScript where there are union types. It makes a lot of sense to return a result or a union of success or error. Freest then generates a when method. And this is where things get really nice. Because this when method, so you get a result union. You don't know which exact type it is. And then you call the when method and you have to define every possible case. So in this case here, what should happen if it's a success? What should happen if it's an error? And you cannot miss any any case. There are other methods to check only for certain cases, but then you have to implement an or else method to handle all the remaining cases. And I recently implemented it, and it made my project much better. Instead of an API which gives me a result or a random list of certain errors or exceptions, which nobody really checks, it now gives me a result union, and I have all the possible cases. And it looks something like, the next example will come later. I just want to make an honorable mention to super enums. Super enums is another library to create data classes, basically. It is built on top of enums, so you're actually creating a private enum with multiple values, and then you can add annotations to it to create the class behind for that value. It is a bit complicated, but it worked. And I used it before, and last week I ripped it out and replaced it with the other library, Freest. And now my code is a bit better, and those data classes or union types are now easier to read and to maintain. This here is a big example. So I have multiple error cases, so wrong password, could not reach the server, or inconsistent data, things like that. And each case can return the error case and additional parameters. For example, the inconsistent data type has a message included which includes what's inconsistent. And it could be any type. The problem with super enums is that it rarely supports lists and maps. It simply doesn't work well. Whereas with Freest, there is no limit in what types you put into the constructor or the factory constructors. I quickly want to go back because I want to highlight one more thing. The result union error here uses a message as a parameter, and it's annotated with nullable. By default, Freest will add asserts for everything, so it always checks that things are not null, the arguments are not null. Because non-nullable by default is coming very soon, and this library is already prepared. So if something can be null, and you are very sure that it can be null, you currently can define the nullable annotation, and then the asserts will not be included, and you can put null as a value. So I think we now created a better Dart. If you put all those three libraries in your project, you reached a point where Dart and Kotlin do not look much different. Actually, the only difference is that Kotlin has no semicolons, and Dart is at some point a bit verbose. But in the end, combining all those libraries makes a great project, and if you're writing domain language or domain specific code, business logic, those are your essential tools to write good APIs. Thank you very much.